So quickly, let's move to the next example. Example 1D. Example 1D says find the value of E if 4E plus 9 equals 21. So here we have 4E plus 9 equals 21. Okay, the question is, could we apply the principle divide both sides when we get to this stage while solving a mathematical problem? And if we could, what do we divide both sides by? Okay, the first thing I told us, if you remember, is that we must ascertain the fact that the term containing the variable we are looking for is alone on one side of the equation, sometimes right, sometimes left. That doesn't really matter. So what matters is the term containing the variable we are looking for. In this case, we are looking for the variable E. Find E, find the value of E. So we are looking for the variable E, and the term containing the variable E is 4E. Other terms are 9 and also 21. So 4E must be alone on one side of the equation, just as 5M is alone on one side of the equation here, just like 13xy, the term containing the variable we are looking for, x in this case, is on one side of the equation here. Also 7x is on one side of the equation here, alone. So, but here in this case, 4E is not alone on the left hand side of the equation. So we cannot apply that principle. So we cannot divide both sides. Okay, let me just write can't divide both sides by anything. At this stage. Sorry, I will have to reduce the size of my handwriting so it will contain this little space we have here. Okay. Can't divide both sides by anything. At this level. So you cannot divide both sides by anything at this level, at this stage of solving these equations. When you get here, you can't. Why? Because 4E, which is the term containing the variable E we are looking for, is not alone here. Plus 9, the term 9 is also with it, so you can't. But that doesn't mean the question cannot be solved. What it means is that you can actually apply one of these. There must be another principle to be applied here, and you agree with me that principle is just to collect like terms, though we are going there, and that's the next principle we'll be considering though. So but for the sake of these subtopic divide both sides by, also we just end here. We cannot divide both sides by anything at this stage. Okay? So as I said, okay, let's just solve it and perhaps we'll get to that stage where we could divide both sides by something. So we have 4e plus 9 equals 21. So what do we do from here? We collect like terms. So what does it mean to collect like terms? Okay, don't let me explain that now. When we get there, I will explain better. So, but just watch me as I do it. So 4e equals 21 minus 9. Okay, the reason I may eventually explain what collecting like terms mean here. Okay, so what it means to collect like terms, as it said, like terms that look alike. So 4e is a term here, 9 is a term, 21 is a term. You'll notice that 4e is the only term that contains a variable here, so that's why I maintained it on that side of the equation. And terms 21 and 9 are like terms. They are just whole numbers, so they are like terms. So I collect them together. I make sure they are together. So on the other side of the equation, that's just what it means. But you notice that on the sign for 9 changed. It changes. Why? Because there is a rule in mathematics that says if a number or a term crosses the equals to sign, the sign of that number, of that term, must change. So if it was plus before, it changes to minus, and if it was minus before, it changes to plus. So in this case, it was plus 9 before, so as it crosses the equals to sign, it becomes minus 9. You notice that 4e is not crossing the equals to sign, is on the left hand side of the equation, is still on the left hand side of the equation. 21 also is not crossing the equals to sign, it is on the right hand side of the equation, and it is still on the right hand side of the equation. So it's only 9. So from plus 9 it changes to minus 9. So let's proceed. So we have 4e equals 21 minus 9. That's 12. Okay, so you will notice that now we have to do something to make sure that this example looks like the first example that we solved. 7x equals 56, 4e equals 12. So at this stage of the of solving the question, we could not divide both sides by anything. But at this stage, you notice that we could. So 4e is now on one side of the equation alone, and every other term is on the other side of the equation, and therefore we could divide both sides. Divide both sides. So by what? Of course, by the coefficient of e, which is 4 in this case. So on the first side we have 4e, and on the second side we have 12. So you divide the first side by 4, the second side also by 4. 4 here 1, 4 here 1. 4 here 1, 4 can go in 12 3 times. And therefore, the variable e we are looking for equals 3. So that's the final answer. So let's quickly we'll go just solve the last example. We have example 1e. The question says solve 2 all over 3x equals 6. Now, understanding what this means is very, very crucial. 2 over 3x. Now, as I call it, 2 all over 3x, right? 2 all over 3x. They are not the same. But what they are actually pointing to in this question is this: 2 all over 3, then x. Just like 7x. Forget the fact that this is a fraction. It's just like, it's the coefficient of x here. But here, 2 over 3 is not the coefficient of x. This means 2 as the numerator and the denominator is 3x. So they are not the same. Don't mix them together. Okay? Alright. So what we actually have is 2 all over 3x. 2 over 3 as the coefficient of x equals 6. So 2 over 3 x equals 6. Okay, now before I proceed into solving this question, I also love to mention something. Now here, it's this 2 over 3x also means 2x all over 3. It's the same. Okay, let me prove that to you. When you have this means 2 all over 3 times x, right? Okay, so when you have these in mathematics, I always tell students that whenever you are working with fraction and you have a whole number, the best thing to do is to make that whole number all over 1. So instead of just writing x here, you just make it all over 1 because we are working with fractions. Okay, so 2 times x, 2x, and also 3 times 1, 3. So 2 over 3x is the same thing as 2x all over 3. And that will lead us to what I want to mention now. And please listen attentively. So whenever you are multiplying a fraction with a whole number, so just note that, for example, if you have 7, which is a whole number, and you have to multiply by maybe 3 over 8, a fraction. So what you have to do, what this means is you just multiply the whole number by just the numerator of the fraction. So this will eventually give 7 times 3, that's 21, all over 8. So what this means is 7 into bracket 3, 7 all over 8. So that's that about that. Let's just take note of that. So you don't multiply with the denominator, just the numerator alone. Okay? Sorry. Back to the question we have. So 2 over 3 x equals 6. Could we divide both sides by something? Yeah? Yes, we could. Why? Because the term containing what the variable we are looking for, which is 2 all over 3x, is on one side of the equation, and every other term is on the other side of the equation. So we divide both sides by what? Remember, we have to divide both sides by the coefficient of the variable we are looking for. So in this case, the coefficient of x, which is 2 over 3. Forget the fact that it is a fraction. Just maintain the principle. Just maintain the method. Make sure you apply the method very well. Be it fraction, decimal, or whole number. So we divide both sides by 2 over 3. So in the first side, we have 2 over 3x, and the second side we have 6. So you divide the first side by 2 over 3, and the second side by 2 over 3. Okay? 2 over 3 here 1, 2 over 3 here 1. Okay, so we have x equals 6 all over 2 over 3. Okay, I love these, and this will make me explain another very crucial thing that could cause a mix-up while solving mathematical problems. So here we have x equals 6 all over 2 over 3. How do we deal with these? There are more than one over there. Okay, let's not forget that over means divide actually. So what this means is 6 divided by 2 over 3. So what I advise students to do at this point is the major all over should be made division sign. Nothing changes. So the major all over is this one, 6 all over 2 over 3. So the major all over is that that separate 6 and 2 over 3. So we just make it division sign. This is what I mean by that. So x equals 6. Instead of writing all over, we make a division sign. Divided by 2 over 3. Do we understand? I'm sure we do. So it looks more, we can relate better with this than this. So remember I said the other time that when you are working with fraction, you make every whole number. You make the whole number what? Over 1. So 6, instead of writing just 6, you make it 6 all over 1. And also, remember you don't cut with division sign. You don't cut with division sign in mathematics. So what do? You change the division sign to multiplication sign, which you can cut with. And if that happens, you have to change the arrangement of the next fraction. It's 2 over 3, but the numerator will come down and the denominator will go up to have 3 all over 2. So from here, we could cut 2 here 1, 2 here 3. And therefore, x will be what? 3 times 3, and that is 9 all over 1. 1 times 1 is 1, and 9 over 1 is also the same thing as 9. Alright? So, with these 5 examples, I believe we understand the stage to apply the principle of dividing both sides by something. And we also know what to divide both sides by in whatever case. So, that brings us to the end of the first principle, dividing both sides by something. Thank you.